Hi friends, welcome to my channel. This video we are going to see about gamma function and their properties. Okay, so gamma function. The gamma function usually the people is called as a Euler gamma function. Okay, they call this a Euler gamma function. So this is denoted by capital gamma letter. So we always denote the capital gamma x. Okay, this is the Greek letter capital gamma function. If you are using small gamma, it has a different meaning. So please keep in the mind. Okay. And some people write it as gamma is like that. It is also not correct. Okay. Please keep in those things. So it is defined for every number system. Okay. Real and complex number. It is some people called as a extension of factorial function. Okay, because factorial function is defined for only non-negative integers. So the gamma function is defined for all real and complex numbers. It has the various application in mathematics, science, and engineering. Okay. Now we can go and define the what is the definition of gamma function. Gamma function is defined by capital gamma function equal to integral over 0 to infinite t power x minus 1 exponential of minus t dt for x is greater than 0. So keep in the mind whenever x is greater than 0, but I given the example in the introduction, it is function for real and complex numbers. So it may you feel that it is a contradict, no need to worry, I will explain further. Okay. Now first we are going to find the properties of the gamma function. For the time being, you take the equation, this is the equation number 1. Now we will define the first function, gamma of x plus 1 equal to x times gamma of x. So we are going to prove this thing. So gamma of x plus 1, what is the meaning? Integral over 0 to infinite x t power x times exponential of minus t dt. Now using the integration by parts formula, what is the integration in parts formula? If I take it u equal to t power x, this implies du equal to x times t power x minus 1 dt. So v I take it as dv I take it as exponential of minus t dt. This implies v equal to minus times exponential of minus t. Correct? Now apply the result here. U times v, so t power x times exponential of minus t, so 0 to v. Now I take it as limit v tends to infinite plus minus integral over 0 to infinite t power x minus 1 times x, I will take the outside, and minus time exponential of t, so I will take it as, so here also I must go minus, so times exponential of minus t dt. So this limit if you are evaluate, will automatically it's going to 0. From our usual mid process calculus you will get this result. So this guy become, this guy is equal to x times, this is nothing but gamma of, this is the result only I want to prove it. Correct? So this is the first property. I will take it as this guy is equation number 2. So I will use it this result. Okay. Next result is gamma of 1 equal to 1. This is the most important property. That is why this result is most important. Now why I will say, I will explain why it is more important. Gamma of 1 equal to integral over 0 to infinite x power 1 minus 1 t power 1 minus 1 times exponential of minus t, correct? So this t power 0 is 1, so I will take integral over 0 to infinite exponential of minus t. So if you are integrating, you will get minus limit v tends to infinite minus term exponential of minus t. Limits are 0 to v. So whenever you are going to v tends to infinity, this guy is going to 0. Lower limit is become minus 1. So 1. So here also minus and lower limit minus 1. You get it as simply 1. So gamma of 1 equal to 1. This is our third problem. I will take it as that. From the definition 1, and this is the equation number 2, and this is the next property is, suppose I choose it, n is an integer. Suppose I take it as n is an integer, gamma of n equal to, I can write as n minus 1 times gamma of n minus 1 from equation number 2, or this result. I can write it as gamma of n is n minus 1. So this implies, so then n minus 1, gamma of n minus 1 I can write it as n minus 2 times gamma of n minus 2. I repeat this process, you will get it is n minus 1 times n minus 2 and so on, 1 times gamma of 1. So this implies gamma of 1 is, I know that is 1. So this becomes n minus 1 factorial. That is for gamma of n. So this is the reason. Now I take this is the equation number 4. So this is the equation number 4. That is why gamma function is also known as the generalization of factorial function. So this another thing, this is why 0 factorial is 1. We are always taken in our definition, correct? Whenever 0 factorial is 1. Why this result is coming? Because 0 factorial means what? This is nothing but gamma of 1. Gamma of 1 is, we already proved that gamma of 1 is 1. This is the reason only 0 factorial is 1. We define such a